Today, we're going to dive into the absolutely monumental task of building a new generation of eco-friendly container ships. We're talking about giants designed to literally change the future of global trade. And it all kicks off with this one number, 90%. That's how much of all international trade travels by sea. I mean, just think about that for a second. The phone in your hand, the shoes on your feet, chances are they spend a good amount of time on the open ocean. So that leads to a huge question. With 38,000 of these massive ships out there right now, how do we make all of that trade cleaner? The race isn't just about building bigger ships anymore. Nope, it's about building smarter and a whole lot greener. And that's where this mission comes in. One company took on a truly historic challenge: build 9 of the world's largest, most eco-friendly ships, and do it all in an incredibly tight 2-year timeline. So to really wrap our heads around this project, we first have to understand the sheer scale of what we're dealing with. These aren't just ships. They're basically floating cities made of steel. Let's just try to put these numbers into perspective. We're talking about a ship that is 400 meters long. That's like laying 4 football fields end to end. It weighs 70,000 tons before you even put a single container on it. That's the same as 7 Eiffel Towers. And its capacity? Well, if you lined up all 23,000 of its containers, that line would stretch for an unbelievable 150 kilometers. So, you might be wondering, how on earth is it possible to build 9 of these monsters in just 2 years? Well, the answer is pretty revolutionary. You don't build them piece by tiny piece. You build them in huge chunks, like a city-sized puzzle. And the whole process starts with an almost unbelievable temperature. A super specialized laser heated to 18,000 degrees Celsius. Let me say that again. That's 3 times hotter than the surface of the sun. Slices through these massive steel sheets like they're butter. So here's how this modular method actually works. First, that crazy hot laser cuts the steel with perfect precision. Then, workers weld those sheets together into these enormous, pre-made blocks. And finally, gigantic cranes lift these blocks into place to form the ship's structure. And the scale of these blocks is just, well, it's mind-boggling. Some are the size of a single room, while the biggest ones are as tall as a multi-story building. But here's the really impressive part. They come pre-fitted with all the pipes and wiring already installed inside. It's genius. Okay, so once all those blocks are in place, the welding begins. For just one ship, the total length of welding is an astonishing 1,250 kilometers. And every single inch of that weld has to be absolutely perfect because, well, the ocean does not forgive any mistakes. But the real revolution here isn't just the size of the ship. It's what powers it. And that presented one of the biggest engineering puzzles of the entire project. See, this ship runs on liquefied natural gas, or LNG. Environmentally, it's a huge win. But there's a catch, a big one. To stay liquid, LNG has to be kept at a constant, bone-chilling minus 161 degrees Celsius. So that's the multi-billion-dollar question for the engineers, right? How in the world do you build a fuel tank that's big enough to cross an entire ocean, but is also insulated enough to maintain that extreme temperature without a single problem? The solution? You build the world's largest thermos. I'm not kidding. This fuel tank is so huge it could hold 6 Olympic-sized swimming pools. It's an absolute marvel of engineering, built with layers and layers of insulation and a special kind of space-age steel that can actually shrink and expand with the extreme cold without breaking. And the payoff for all that incredible work? It is immense. Compared to the old, dirty fuel, LNG cuts sulfur dioxide emissions by a staggering 99%. It cuts general air pollutants by 91% and carbon dioxide by 20%. This is a massive leap forward for cleaner shipping. So, with the hull and that revolutionary fuel tank complete, it's time to bring in the other titans, the massive components that give this ship its unbelievable power. First up is the engine. And this is the largest natural gas engine ever built. It stands 6 stories tall and weighs over 2,000 tons. It's actually so big that maintenance crews can literally walk around inside of it. And what does that colossal engine turn? This, a single-piece propeller that weighs 92 tons and stands 10 meters tall. Just try to imagine the raw power it takes to spin that thing.
Once the main hardware is in, the entire structure, we're talking an area double the size of Vatican City, gets coated in 1 million liters of specialized paint. And that's not just for looks, it's absolutely crucial for protecting the steel from corrosive saltwater. And then finally, the command bridge, the brain of the ship, is carefully lifted into its rightful place. So, after more than a year and a half of non-stop construction, the first ship is finally complete. But before it can take on the world's oceans, it has to prove that it's ready. And the pace of construction was just incredible. That first ship was fully assembled in only a year and a half. It then spent 15 days in grueling sea trials, where every single system, from the engines and emergency brakes to the navigation, was pushed to its absolute limit. And amazingly, the shipyard delivered all 9 ships right on schedule. And during these trials, nothing is overlooked. Even the anchor is tested over and over. And just to give you one final bit of perspective on the incredible scale here, a single link in that massive anchor chain weighs 300 kilograms. This whole project is really more than just a story about a ship. It's a powerful testament to what's possible when human ingenuity decides to move mountains of steel across the most unforgiving seas, all in the name of a greener future for all of us.